The sandwich theorem says as like this: suppose that gx is less than fx less than hx for all x in some open interval containing c. What does this mean? That you have got a function fx, the blue function, that is contained between two functions, the hx, the red one, and gx, the yellow one. So this my blue function is contained between this red and yellow function. So fx is contained between gx and hx for all x in some open interval containing c. So if I have my c's here, this is my open interval, and between this open interval this blue has to lie, say like this, between the red one and the yellow curve. It may be that after this interval this blue may go here, or this blue one can fall here. So I am not worried about that. What I am saying, what this theorem is saying, कि about some interval, says this c, there should be an open interval about this point where this blue function should be contained between this hx and gx, except possibly at x is equal to c itself. This is also very important. It may be that x is equal to c, my blue may be somewhere here. That is quite possible. So this does not say anything about value of this function f at x is equal to c, because limit does not depend upon value of that function at that point. So except possibly at x equal to c. So this is the sandwich theorem, that suppose the fx lies between these two functions except possibly at x equal to c itself, and suppose also that g tends to limit L and h also tends to limit L, that is limit x tending to c gx is equal to limit x tending to c hx is equal to L, then limit x tending to c fx will also be L. So this is the sandwich theorem. So this is the mathematical statement of this theorem. I can explain it to you by giving us a simple analogy. Suppose you are a poor small boy in a classroom, okay, or a very obedient kind of boy, very thin boy. Suppose you are stuck between two big boys who are bullies, like this, okay, this is boy 1, this is boy 2, and you are stuck between these two things. You cannot go either left or you cannot go either right. That is, you are a small boy, this is you, and you are stuck between these two things. And suppose these two boys who are bullies and maybe rowdies also, suppose they are going to movie. Okay, he is also going to movie, and boy 2 is also going to movie. Then do you have any other option but not to go to movie? Because suppose they are literally, say, dragging you from this boy is dragging you from left side, he is dragging you from right side, and you cannot go beyond them. So if they are going to movie, you will also go to movie. The exactly same thing is happening with this poor chap f also. This f is contained, this is sandwiched between this gx and hx. Now since this gx is going to L, this hx is also going to L. So a poor f who is contained between these two gx and hx, it has also go to L. It cannot go to any other value apart from L. So this is a sandwich theorem. I will give you one example also of this thing. Suppose given that ux is a function contained between 1 minus x square by 4 and 1 plus x square by 2. So this is my function, this is blue one, y is equal to ux, contained between 1 plus x square by 2 and this is 1 minus x square by 4. And suppose you have to find limit x tending to 0 ux, no matter how complicated u is. Then can you tell what will be the value of this limit? You see, this 1 minus x square by 4 and this is contained between ux 1 plus x square by 2. Now as limit x tends to 0, this goes to 1. Similarly, this also goes to 1. So this ux has to go to 1, no matter what may be value of this function. That is immaterial. This ux has to have the limit 1. So this is sandwich theorem. Now I will give you another example. Discuss the limits of limit x tending to 0 sine 1 by x. Can you say whether this function will have limit or not? No, this function will not have limit, because as you go closer and closer to x, what is happening? This 1 by x is becoming a very large number. And since this sine 1 by x, it lies between plus 1 and minus 1, but it will be oscillating like this, you see. So its value will be something, sometime it will be plus 1, sometime it will be say half, sometime it will be 1 by 3, sometime it will be minus 1 by 3, minus 1 by 2, minus 3 by 4. So it can be between any these two limits, plus 1 and minus 1, but it will not be a fixed number. So this function sine 1 by x will not have limit, so this will have no limit. But what will be the limit of this thing? You see, this is also exactly same thing as sine 1 by x, but you have got an extra x here. So this x will have a modulating effect. It will, what it will do, you see, when I draw a curve of this function x sine 1 by x, although it is also oscillating very furiously near x is equal to 0, but this is limited by these two functions, because you see y is equal to x. So this amplitude of oscillation cannot increase, cannot be more than x, because you see minus 1 is less than sine 1 by x, less than 1, this I know. Similarly, if you multiply by modulus x, you will get this thing. So your x sine 1 by x has to lie between modulus of minus modulus x and modulus x. It has to lie between these two things. Now as x tends to 0, this also goes to 0 and this also goes to 0. So by applying the squeezing theorem or the sandwich theorem, this thing will go to 0. Ultimately what is happening, you see, because this sine 1 by x, it is bounded both below and above by this thing y is equal to modulus x, because you see, since sine 1 by x can take plus value also, minus value also, that's why this function is going up and down and it will be bounded by y is equal to plus x and y is equal to minus x curve. Okay, so since it is bounded and the amplitude is governed by this x, and this x is going to 0, so your amplitude is going to 0, so your whole thing, although oscillating very rapidly, but it has to go to 0. Now let's see. I had told that we will be discussing the one-sided limit. So this is a theorem. A function fx has a limit as x approaches c if and only if it has left hand and right hand limits there, and these one-sided limits are equal. I had shown you another last example also. Suppose take this example, y is equal to x by modulus x. So for x greater than 0, this function will be 1. Similarly for x less than 0, it will be minus 1. So suppose I have to find limit at say point 0. If I approach this point 0 from this side, what will be my limit? I will be approaching through all these points, will be 1, here also 1, here also 1, here also 1. So ultimately this limit should come out to 1, this will be 1. If I approach this point 0 through this direction, if I approach it through this line, what will we have? Here also minus 1, here also minus 1, here minus 1. So ultimately this limit will be minus 1. So this is plus 1, this is minus 1. These two are not equal. Therefore, there will be no limit at x is equal to 0. So for a function to have a limit at say limit x is equal to c, the left hand limit and the right hand limit both have to be equal. If they are not equal, then you can say that okay, this is right hand limit, this is left hand limit, and they are not equal, so the function is not having limit. So this is the curve. Suppose this is my y is equal to fx and I have to find limit at say c. So right hand limit as x approaches c, meaning you are approaching from right hand side, that is you are approaching from values of x which are greater than c. Okay, so this x is greater than c, I am approaching from this side. Similarly for left hand limit, I am approaching this c from this side, that is from value of x which are less than c. So this is right hand limit and this is left hand limit, and if the function has to have limit at x equal to c, these two limits have to be equal, otherwise the function will not have limit at that point x is equal to c.